Hello and welcome to week 11 of CNET 56. I want to share my screen. And this week we are going to look at Module 8 in the lecture material, which is on segmentation. And this is where we're also going to continue to look at our subnets. So last week's lab, of course, you did a lot of binary and network subnetting, right? You had to create some networks and look at some network IDs. So this week is going to explain why you want that. Why do we want smaller networks? And one of the concepts here is efficiency. So it's going to enhance security, improve performance, then it's going to make it easier to troubleshoot. So the smaller your area is, the better it is as far as performance. And then it's also easier to kind of find where the problem areas are if you're looking in a smaller area. So sometimes our networks are segmented by department, maybe by devices, right? Like maybe we have a section of Macintosh computers in our network and another department that uses Linux and another department that uses Windows. So we may want to, kind of keep those separated. And here's a concept of a broadcast domain and our segmented network. Now, a broadcast domain is an area where everybody can hear everything, right? So we want to separate or make smaller those broadcast domains. Now, the device that breaks up our broadcast domain are routers. So routers do not propagate or send broadcast traffic. So if we have our network and then we have a router, then another network, those two networks, which are defined by that router, will create two broadcast domains. So if we were to look at, say, this network, where we have a router, and then we have, this router obviously has 4 connections, one to the internet, one to subnet 3, one to subnet 2, and one to subnet 1. So this router would have 1, 2, 3, 4 broadcast domains. So any traffic on this network will not be seen by these other devices. Now, that doesn't mean this PC here cannot communicate with this PC, because if we have our routing protocol set up where we allow that, then they could. But when this device says, hey, where is this printer? I'm going to scan the network. It will not look and see this printer because it's on a separate subnet. All right. So here's kind of a review with the binary and the subnet mask, and then some information on where you borrow bits from either the network host or network information or the host information, so you can make it bigger or smaller by doing that, and so forth. So I'm going to go down here again and look at this topology. So if we were to say, how many broadcast domains are there? A broadcast domain would be each segment of this router. So if we were to count these here, let me get my marker here. So we would have 1 broadcast domain, 2, 3, 4, 5, 6, and then 7. So wherever we have an interface on this router, that will be a broadcast domain. All right. So if we, oops, that should be there. Now I'm gonna clear that. All right. So if we were to look at how does DHCP work through that, DHCP uses UDP, which is not routable by default. We would have to put on our DHCP server what's known as a relay agent, which basically tells our DHCP client that's saying, hey, I need an IP address. When that traffic gets to the router or the DHCP server, it will forward it through it. Okay. So they'll do that. Now, what we've been doing with that CIDR notation, the slash notation, is when we change our class addresses, our class A, class B, class C, to smaller or larger, and then we can use a non-class subnet mask, right? So like class A has a default subnet mask of 255.0.0.0. If we change that to 255.255.255.128, right, like we did in last week's lab, that's what's known as a variable length subnet mask. So basically, it gives us the flexibility to do that. So here, we can create a big subnet for our sales, a small one for exec, IT, and HR, then a medium-sized subnet for accounting. And assuming these are connected by a router or a layer 3 device, they will be able to communicate or not communicate, depending on our rules. All right, so here we can say this is a /25 network, this is /26, /27, /29, 29, /30 for our WAN, and then we have a chunk of it that's unused. So we have one network with 1, 2, 3, 4, 5, 6, 7 subnets in it. So we could subdivide our network down into that. All right. And here's some information on IP version 6. We're going to come back to that later on. But here's a question similar to the question in last week's lab. If a server has a subnet mask of 255.255.255.224, how many bits in its IP address identify the host? So let's look at this, and let's just put this last octet in binary. So 224 is 128, 64 is 192, and then 32 is 224. So we have 3 network bits, and then we're going to have 8 total bits, right? 3, but we have 5 zeros. So saying how many bits are for the host, and that would be 5 bits, right? Because we have 8 bits. So here's 8, 8, 8, and then another 3. So this would be a /27 network, but that's not the right answer. The number of zeros here would be the correct answer. All right, clear that. All right, so, and you should be able to start to get some of these in your head. So here's some answers there. Right, then there's another section on VLANs, which we're going to do a network lab where we'll create some virtual LANs. And then I want to talk briefly about collision domains. All right, so let me pull up something here. All right, so here, this is from Cisco. And as you can see here, I'm going to make this larger. A collision domain is where packets can collide. Now, collisions are often in a hub environment because each port on the hub is the same collision domain. However, each port on a bridge or a switch is a separate collision domain. So if we were to look at this topology here, make it just a little bit smaller, and we were to say, where are our collision domains? So I'm going to snip this real quick. All right, so if we were to say, where are our collision domains, we would have one here with this hub, then each switch port. So there's 1, 2, 3, 4, 5, 6 different collision domains. Now, because this hub is connected to the switch, that's all one big collision domain. All right. So let's take a look at this area. And here we have the router. Now, these are our broadcast domains, right? Because what defines our broadcast domains is our router interfaces. So here's one broadcast domain, another broadcast domain, which gives us 3 broadcast domains. Now, how many collision domains are here? It happens to be the same, 1, 2, 3, because this is a hub. Now, if we come back in here, let me just do an image search for collision domains. And let's look at this image here. So how many broadcast and collision domains? So we have one router with 2 interfaces. So we have 2 broadcast domains, and then every interface. So between this router and this switch, that's 1 collision domain. This port is another 2. Here. So because these are switches, each connection is its own collision domain. All right. So I'll talk about this some more in the lab. So let me just kind of review this week. So of course we have the discussion, which is your initial is by Wednesday, your 2 peers are on through Sunday. Quiz 8 is also due this week. We have labs 11, which is going to deal with Telnet, VNC, and proxy servers. So we'll do some work with our CentOS virtual machines in VirtualBox. All right, so make sure you read this lab. And then there's a section where we'll set up Squid, which is the proxy server. And then I'll have you go grab these text files, which really are just going to contain the information that you'll just copy this and then paste it into your setup, and it will change your Squid server. So it's a really easy way to configure that for us. All right. And then of course we have, there's a section in the lab that will have to do with security. So we're going to start talking about security, and we're going to use this pretty good privacy security information. So again, here's some routers with switches for collision domains and stuff. Now I'll mention that. So here's where you'll do the proxy. And then there's a section here with pretty good privacy, right? So this is going to be pretty easy, pretty straightforward, and you'll be able to work your way through this in lab this week. All right. So let me stop my share. And that should give you a good idea of what we're doing in week 11. And I'll see you in lab.